Using the NASA ESA Hubble Space Telescope, astronomers have found the first clear evidence of high-altitude haze or clouds in the atmosphere of an extrasolar planet. This discovery reveals a deeper understanding of the class of giant planets that astronomers call hot Jupiters. Using the Advanced Camera for Surveys, or ACS, the Hubble Space Telescope has recently observed a fascinating large gaseous planet around the star HD 189733. Careful analysis of these very high-precision observations by a team led by Frédéric Pont from the Geneva University Observatory showed that this planet, designated HD 189733b, possesses a murky haze layer extending over an altitude range of about 1,000 kilometers in the planet's upper atmosphere. The atmosphere of this gaseous planet is at around 800 degrees Celsius. This is due to its proximity to its parent star and is the reason that astronomers call this type of planet a hot Jupiter. These hazes are probably made of tiny condensed particles less than 1,000th of a millimeter across, similar to those already known on Venus and Saturn's moon, Titan. Their presence means that the sky over HD 189733b would look very much like a red hazy sunset viewed from an industrially polluted city on Earth.
To detect the hazes, astronomers actually had to do quite a bit of detective work. Now, the reason why this work was possible at all is because from our vantage point, the orbit of HD 189733b is seen almost exactly edge-on. Now, what that means is that every 2 days or so, the planet actually moves across the face of its parent star as seen from here. Now, when that happens, some small fraction of the light from the star has to pass through the atmosphere of the planet in front of it in order to reach Earth. Now, because of this process, the composition of the atmosphere of the planet is stamped onto the light like a unique fingerprint. Astronomers can then see this fingerprint in the spectrum of the star's light.
The astronomers were expecting to see clear signatures of sodium, potassium and water in the planet's atmosphere. The fact that these were not seen led them to this conclusion that they were being masked by red-coloured high clouds or haze. According to the scientists, the haze probably consists of tiny particles, condensates of iron and silicates.
When extrasolar planets were first discovered about 15 years ago, little did we know how quickly we would begin to unravel their secrets. The new Hubble observations are an important step towards a better understanding of these amazing planets outside our own solar system. Who knows what we will discover in the next few years about these distant worlds?
The NASA ESA Hubble Space Telescope has discovered an extrasolar planet, for the first time using direct visible light imaging. The strange world is far flung from its parent star, is surrounded by a colossal belt of gas and dust, and may even have rings more impressive than Saturn's. Fomalhaut is visible from the southern hemisphere, and is one of the brightest stars in our night sky. Lying around 25 light-years distant, it's also relatively close. Fomalhaut is much hotter than our Sun, and 15 times as bright. It's blazing through hydrogen at such a furious rate that it will burn out in only 1 billion years, 10% the lifespan of our star. But perhaps its most interesting feature is the large disk of gas that surrounds it, looking like a lifebelt. It's this ring which first sparked the attention of astronomers. It isn't centered on Fomalhaut quite as predicted, hinting that the gravity of another body, perhaps a planet, is pulling it out of shape.
And so Hubble was called upon to solve the mystery of the misshapen disk. And, lo and behold, the image produced by Hubble actually does show a planet. It orbits Fomalhaut at an enormous distance, about 10 times the distance between Saturn and the Sun. In honor of its parent star, astronomers have given this planet the extremely catchy and very imaginative name Fomalhaut b.
Planets around other stars have been detected before, but usually indirectly by looking for clues, like the wobbling motion of a star as a planet orbits it, or a star getting dimmer as a planet passes in front of it. This time, Hubble has given us a rare direct image of an extrasolar planet, and what's more, the first invisible light, the type our eyes naturally see.
Amazingly, Hubble has managed to take a snapshot of this planet not just once, but twice, with almost 2 years in between. Being able to actually see the same dot of light moving around the central star is a very clear sign that this object really is in orbit, and that it's not just something that happens to lie along the line of sight. Now, astronomers have calculated that it takes this planet about 872 Earth years to complete one orbit. Now, taking an image of an extrasolar planet is a very tricky business. Fomalhaut is one of the brightest stars in the night sky. By comparison, the planet is just a very tiny dot of light. Now, being able to see that light was only made possible once most of the light from the star was blocked using an instrument called a coronagraph.
So Hubble managed to peer through the glare and view the planet directly. Then clues were gathered to paint a picture of this exotic world. The shape of the disk hints that the planet is at most 3 times the mass of Jupiter. And the observations show that Fomalhaut B is much brighter than expected for an object of its size. It could have an enormous ring system, much larger than Saturn's, reflecting starlight in all directions. One day the material in these rings may even coalesce to form moons.
The holy grail of current exoplanet research is the detection of a rocky, Earth-like planet in the habitable zone, a region around the host star with the right conditions for water to be liquid on their surface. The latest result from the European Southern Observatory comes closer than ever to attaining these goals.
We'd like to tell you about the discovery of the smallest, or rather lightest, and possibly most Earth-like planet so far discovered outside of our own solar system. We'd also like to report on yet another planet within the same system that has now been shown to lie within the habitable zone of its parent star, meaning that it could host liquid water and possibly even life.
Gliese 581 is a seemingly inconspicuous red dwarf star located 20.5 light-years away in the constellation Libra, or the Scales. It is among the 100 closest stars to us and weighs only 1/3 the mass of the Sun. Such red dwarfs are intrinsically at least 50 times fainter than the Sun and are the most common stars in our galaxy. For astronomers studying exoplanets, red dwarfs are ideal targets for the search for low-mass planets where water could be liquid. Because such dwarfs emit less light, the habitable zone is much closer to them than it is around the Sun, which makes it easier to detect the planets.
Now, what they found was that Gliese 581 is orbited by a planet that has only 1.9 times the mass of the Earth. This planet is known as Gliese 581e, and it is the lightest and most Earth-like planet so far discovered outside of our own solar system. Now, within the very same system, the team also refined the orbit of a previously known planet called Gliese 581d. What they found was that this planet is definitely within the habitable zone of its parent star. Now, what that means is that the planet is just at the right distance from the star for any water that might be present at its surface to be liquid. If it were any closer, the radiation from the star would be too strong and the water would evaporate. If it were any further away, it would be too cold and the water would freeze.
From previous observations, also done with the HARP spectrograph at ESO's La Silla Observatory and announced 2 years ago, this star was known to also harbor a system of 3 super-Earth planets. With Gliese 581e, the planetary system has 4 known planets, with masses of about 1.9 planet E, 16 planet B, 5 planet C, and 7 Earth masses planet D.
The planet with the largest orbit in the system is Gliese 581d, and it takes about 66.8 days for one round trip around its parent star. Now, because it orbits within the habitable zone of its star, this planet could be covered in liquid oceans, making it the first serious water world candidate. An exoplanet orbiting a star that entered our Milky Way from another galaxy has been detected by a European team of astronomers. The Jupiter-like planet is particularly unusual as it is orbiting a star nearing the end of its life and could be about to be engulfed by it, giving tantalizing clues about the fate of our own planetary system in the distant future. Astronomers have detected nearly 500 planets orbiting stars in our cosmic neighborhood, but none outside our Milky Way has been confirmed. Now, however, a planet weighing at least 1.25 times as much as Jupiter has been discovered orbiting a star of extragalactic origin, even though the star now finds itself within our own galaxy. The star, which is known as HIP 13044, lies about 2,000 light-years from Earth and is part of the so-called Helmi stream. This stream of stars originally belonged to a dwarf galaxy, which was devoured by our Milky Way in an act of galactic cannibalism 6 to 9 billion years ago. Astronomers detected the planet by looking for tiny, telltale wobbles of the star, caused by the gravitational tug of an orbiting companion. The planet, HIP 13044b, is also one of the few exoplanets known to have survived its host star massively growing in size after exhausting the hydrogen fuel supply in its core, i.e. the red giant phase of stellar evolution. HIP 13044b is near to its host star. At the closest point in its elliptical orbit, it is less than 1 stellar diameter from the surface of the star, or only about 0.055 times the Sun-Earth distance, and it completes an orbit in only about 16 days. The astronomers hypothesize that the planet's orbit might initially have been much larger, but that it moved inwards during the red giant phase. Any closer-in planets may not have been so lucky. Astronomers suggest that some inner planets may have been swallowed by the star during its red giant phase. Although the Jupiter-like exoplanet has escaped the fate of these inner planets so far, the star will expand again in the next stage of its evolution. When this happens, the star may engulf the planet, meaning it may be doomed after all.